Okay, back at it. And we are going to do the next medium in 2 pointers. So we have this one. To sum 2 input array is sorted. Let's take a look. So we are given a one indexed array of integers numbers that is already sorted in non-descending order. So we want to find two numbers such that they add up to a specific target number. So we have numbers and we have target. And we want to let these numbers be numbers index something 1, index something 2 of length 2. The tests are generated such that there is exactly one solution. You may not use the same element twice. Your solution must use only constant extra space. One indexed array of numbers already sorted, two numbers such they add up to a specific target number. Let these two numbers be numbers index 1 and numbers index 2, where 1 is less than or equal to index 1, which is less than index 2, which is less than numbers dot length. So we want the indices of the two numbers added by 1 as an integer array of length 2. So there is one solution, and I may not use the same element twice. So we have 2, 7, 11, and 15. 9. The sum of 2 and 7 is 9. Therefore, index 1 is 1 and index 2 is 2. We return 1, 2. So basically, it is a repeat of one. It's basically a repeat of 2-sum, which was an easy question we did before. I recognize that. And the way we solved that was by saying, we have a map that was an empty dictionary, and we enumerated the numbers array. So we had a for loop with I and N to enumerate numbers, because then I becomes the instance and N becomes the element value. So we can look at the difference and the target that we're trying to hit, which is target in this case, not 9. I was looking at this example, but it will be target minus N, which is the value that we are looping over. And we're going to look if the difference is in the number map, which is empty at this point. And what we're going to do is return the, I guess this is where it gets tricky, is because we want to now return index 1 and index 2, because we're returning the indices and not the element values. So we have num map of n equals I, which is the key value pair, if difference is not in num map. So we have num map difference I like this. So this will give us the two values, but if we want it to give the values of the indices, index 1 and index 2, I'm not sure if this approach is the right way to do it. I wonder how you could do that, if it's possible to give the indice instead of the actual values. Just go ahead and skip this part. I'm just trying to think. As keys and their indices as values. How do I return the two indices? Return an I. What? That doesn't feel right. Maybe this would work? Enumarte. Yeah, I didn't think that would work. I wonder why this didn't work. What? That actually worked? Oh my god, I actually figured that out by myself? Oh my god. But I know there's a better solution. But this still beats 92% of people? Dang, I just went crazy on that. You know, I don't know if that's like the way to do it though. I feel like that was too easy for me.
Let's solve LeetCode 167 2sum2. So we're given an input array that's already sorted in ascending order, and we want to find two numbers that sum up to some target that we're also given. So in this case, the target is 9. The two numbers that sum up to 9 in this array are 2 and 7. And we want to return the indices of these two values, but the catch here is that the indexes are as index.
I feel like I cheated.
We don't have to look at the remainder of the array target. So the first combination never equal the target. It's fun. Remember that these indices are based on 1, so the first index is 1, the second index is, so it's not very efficient. But can we use the fact that this array is sorted to our advantage? Let's look at the picture we just drew. First, we eliminated 11 from consideration in the array. Then we eliminated 10. Then we eliminated 7. So we're basically eliminating elements from the end of the array in reverse order. Can we use this to our advantage? This is basically the intuition. Remember, this array is sorted. We can use that to our advantage. So let's try the exact same problem with a slightly different algorithm using what we just learned. Our target is a 1 and an 11. Decrease the total this time. Well, we want to decrease our...
Why would it be better to use this solution where you use the 2 pointers and not the hash map how I did?
Remember, we have 2 pointers left and right solution. So if it's greater than the target, we can our sum by taking the left pointer and shifting it, because we're guaranteed a solution, so our loop will return the solution.
This seems too easy. I don't know if it's because I took a day break, but it seems too easy. I don't know if they want me to do it in the way that I did here, or if it were to be better to use the 2 pointers, because the hash map is way faster. The only difference is that it is not memory efficient because we have the hash map. Maybe that's why. Let me try the other solution and see what kind of result it gets ranking versus the others in terms of memory. And I think it's good to flex that 2 pointers concept because I recognized it within the arrays and hashing, but I didn't solve it within this 2 pointer framework. And it wouldn't have mattered if the array was sorted or not with this method. But let's try and use that idea to our advantage and not take that as something we can just break with the question. So we have a length and we have an r equals 0 because this is the same kind of format we used with the last question, the valid palindrome. And this is beneficial to understanding this question because we're doing the same pattern of looking from the beginning and from the end at the same time until the values pass over each other, or the pointers pass over each other. So we have L and R, where L equals 0 and R equals the length of numbers minus 1. And while L is less than R, we can look at the current sum, which is the numbers value at L plus the numbers value at R. And if the current sum is greater than the target, then we can move that R value that's looking at the very end, or the R pointer that's looking at the very end of the array, minus 1, and we can look at the target, or at the pointer that's at the beginning of the array, and add 1 to its existing value to move that pointer to the right. And if they pass each other, or I guess at the end of every loop, we're going to return L plus 1 and R plus 1. Or I guess this return value gives us the answer, because if it goes through to these two, or I guess if current sum equals target, which is the conditional that is not taken into account for with these first two, we can return the location of the 2 pointers plus 1 to give us our result. So I'll submit this and we'll see what the memory allocation. The memory is definitely better, but it is slower. Interesting. This one uses... Okay, this one is the same thing, except it uses some clever one-liners. I didn't even know I could do this. So this is memory. So this one is, again, I guess what is the difference with this? Well, start is less than end. Oh, this uses kind of the same thing. 0 and length of numbers minus 1. Yeah, it's like the same thing. I don't know, like, what the heck? Why is it better memory? So the best ones don't, the best ones memory-wise don't use a hash map. Wow, that's so crazy how they're so small. 14.4, 14.3, 14.2, 14.1. Oh, is this the upper percentile? How about runtime? Oh, its speed is to the left. Yeah, hash map is, you can use a hash map, but it's not the right, it's not the solution they're looking for. All right, thanks.